Imagine popping a pill that helps shed pounds and controls blood sugar like a charm, but with rumors swirling that it might secretly raise your cancer risk. A groundbreaking new review is here to reassure us, suggesting these GLP-1 drugs are safe and could even shield against certain cancers. Buckle up as we dive into the details. This could change how you view these popular medications. In a thorough examination of clinical trials and lab studies, scientists have scrutinized glucagon-like peptide-1 (GLP-1) receptor agonists, those innovative drugs that mimic a natural hormone to boost insulin, slow digestion, and curb hunger. One cited suspiciously for potentially boosting cancer chances, the latest evidence paints a different picture. No overall increase in cancer rates, and possibly even a protective effect against some types, thanks to better insulin control and immune system tweaks. This review, titled GLP-1 Receptor Agonists in Cancer, Current Clinical Evidence and Translational Opportunities for Preclinical Research, was published in the Journal of Clinical Investigation. For those new to the topic, GLP-1 is a hormone your gut releases after eating to help regulate blood sugar and appetite. Drugs like semaglutide, think Ozempic or Wegovy, and liraglutide copy this hormone to treat conditions like type 2 diabetes and obesity. But here's where it gets controversial. Obesity and type 2 diabetes aren't just about weight or high blood sugar. They're global health emergencies linked to a surge in heart problems and now, alarmingly, to cancers. The World Health Organization has flagged obesity as a risk factor for at least 13 cancer types, including colorectal, affecting the colon or rectum, postmenopausal breast, pancreatic, and endometrial, lining of the uterus, cancers. Think of it like this. Excess fat and insulin resistance create a storm of inflammation and high insulin levels that can fuel abnormal cell growth, turning your body into a breeding ground for tumors. And this is the part most people miss. How metabolic diseases and cancer connect on a cellular level. Chronic low-level inflammation, your body's persistent alarm response, plus hyperinsulinemia, that's when insulin stays too high for too long, act like fertilizers for cancer cells. Insulin, while essential for shuttling glucose into cells, can also promote tumor cell growth and survival. GLP-1 drugs step in as metabolic heroes, providing a safer, more effective alternative to older treatments. The review pulls together evidence from preclinical tests like studies on animals, real-world observations, retrospective studies looking back at past data, and meta-analyses, combining results from multiple studies, to address fears about GLP-1 drugs and cancer. It zeroes in on hot-button issues like thyroid and pancreatic cancers, offering a state-of-the-field update. Take thyroid cancer. Early lab work on rodents showed GLP-1 drugs might encourage thyroid C cells to multiply, sparking worries. Reports from the FDA's adverse event system and a specific study hinted at higher risks, leading to a stern FDA warning against using these drugs in people with a family history of medullary thyroid carcinoma, a rare thyroid cancer. But here's the twist. Many experts now question those findings. The FDA data relied on voluntary reports, which aren't always verified, and the study might have been skewed by factors like obesity or more frequent doctor visits leading to better detection of slow-growing thyroid issues. Most large meta-analyses from 2012 to 2022 found no uptick in thyroid cancer risk, though a few did. For pancreatic cancer, initial concerns from FDA data prompted investigations, but later studies showed mixed or no increased risk, with some even suggesting lower chances compared to other diabetes drugs like insulin. Imagine replacing a treatment that might heighten cancer risk with one that potentially lowers it. That's the promise here. Looking beyond these specific cancers, the picture gets even brighter. Meta-analyses reveal no extra risk for most cancers, and in some cases reduced chances for hepatocellular, liver, carcinoma, colorectal cancer, and even prostate cancer when compared to insulin users. Breast cancer? It seems neutral, no harm, no foul. At the heart of these benefits is GLP-1 drugs' ability to slash hyperinsulinemia, cutting off a key fuel source for tumors. But wait, there's more. Lab studies hint at direct anti-cancer effects, like altering tumor cell energy use, dialing down inflammation and reprogramming immune cells, think tumor-fighting macrophages and T cells, to attack cancer more aggressively, even in animals not overweight. For beginners, picture GLP-1 drugs as not just weight loss aids. but potential allies in reprogramming your body's defenses against malignancy. That said, gaps remain. Most studies focus on cancer prevention, not on what happens to tumors already growing or during treatment. The review urges more trials for cancer patients in therapy or remission, with ongoing research exploring how these drugs help manage weight and metabolism during chemo. Caution is key too. Preclinical results on tumor growth don't always translate to humans, so we need real-world confirmation. Overall, the evidence stacks up. GLP-1 drugs don't spike cancer risk, breast cancer stays unaffected, and mechanisms like lowering insulin and boosting immunity suggest they might actually fight cancer better than expected. Even in non-obese models, lab data show promise, though we await human trials to seal the deal. So, do you buy this reassuring narrative? Or are the lingering warnings enough to make you cautious? Could these drugs be the underappreciated heroes in the fight against obesity-linked cancers? Or is there a hidden risk we're overlooking? What if the real controversy is in how quickly we've embraced them without long-term data? Share your opinions in the comments. Do the benefits outweigh the doubts? Or should we demand more proof before celebrating? Journal reference: Valencia Rincon, Rai R. Chandra V. and Wellberg E.A. 2025. GLP-1 receptor agonists in cancer. Current clinical evidence and translational opportunities for preclinical research. Journal of Clinical Investigation, 135, 21. DOI 10.1172/JI194743. https://www.jci.org/articles/view/194743